Hi guys, in this video we will be solving the segmented problems from TSA sheet by ours, and like all I will discuss all the four problems thoroughly in this video. Not and queens, okay, yeah, it is range query immutable. Why it is not opening? Yeah. So the first one is range sum query immutable. So let me know the code. Yeah. So given the array nums, and we need to handle multiple queries of type, calculate sum of the elements between the indices left and right inclusively, and where left will be always less than or equal to right, obviously, otherwise the query will be invalid. Implement a nums array class. Okay, nums array initializes the object with nums array, and some range should return the range of sum of range left to right. Okay, so I don't think any segmentary is required here, because the term you can clearly read immutable. So what I will do is I will just create a prefix sum array. Let's see the constraints. So it is given that the maximum value of the array can reach up to 10 power 5, and the maximum and the maximum length of the array can be 10 power 4. So at max we can have a sum of 10 power 9, so it will definitely fit in integer type. So we will be taking the integer type prefix sum array, and pref will be new int of nums dot length, and pref of 0 will be nothing but nums of 0, and for all I equal to 1 till n will be nums of length, and pref of I will be plus equal to pref of I minus 1, or will be equal to plus k of I, that is nums of I. Okay, and we can just return the sum of the range from 0 to right, minus, if left is 0 then minus 0, otherwise pref of left minus 1. Okay, I think this should work. Okay, let's try to submit it. Okay, so we are it is doing great, but we are beating only 47% of the Java submissions. Where we can optimize it, I don't think it will be possible to optimize it. Just a small modification we can do nums dot length, like instead of finding it again, we can just store in a variable. Will it be fine now? Yeah, now you can see with a small modification we are now beating 100% of the Java submission, because we are not finding the array length again and again. Instead we are just finding it once and storing it in an array, not in array, sorry, in a variable. Yeah, so that's all about this question, and we can see that the time complexity in answering a single query of some range is order of 1, that is constant, and while order n time is required in pre-processing, also order n extra space is required. Okay, now moving to the next one, that is range sum query immutable. We can clearly see that the question is indeed the same. Instead we can just have a modification at a single index, so we cannot use the prefix sum array again, because whenever say we are updating at index 0, then the whole array should be replaced, and that will cost order n time. And let's say there are many update queries, then we will end up in getting order of n into q time. So two data structure are recommended in such case. One is the binary index tree, also known as Fenwick tree, and the other one is let's say segment trees. So I would be implementing the segment tree here, because segment tree is kind of more powerful, even though it is somewhat less efficient than Fenwick tree, but we can answer queries of different types. For example, queries of type min of a range, max of a range, and others also. So let's not get into the Fenwick tree. Instead, we will be going with the segment tree itself. So let's say we define private int seg, and like it is generally recommended that in the segment tree size should be 4 times the array size. Okay, and now we'll be building the segment tree, and yeah, passing the array, or we can make it global only, private int a. Okay, this dot a equal to a. Okay, now we will be having a build method, private void build. What if we will do is we will make our code a bit cleaner. We will not do like this. We will create a another class itself to like make our code look cleaner. Okay, this class we will be having a private type of int, and we will be having a public secretary function. In that secretary function array will be passed, and we will be having private int n, and this dot n will be a dot length. Okay, and also we will be having private int a, and we will have this dot a equal to a, and now we'll be calling the build function with these parameters, and private void build with the function name. But okay, this one represents the lowest like low index of the segment we are considering right now, and this represents the highest one, and this represents the current node. So if the segment size is 1, that is if low is equal to high, we can say that the sum will be nothing but a of low. Okay, we can simply return from here. Otherwise we will calculating the mid, and like building the left side array or just left side segment tree, and building the right side one. Okay, and now seg of node will be nothing but the sum in the left segment plus the sum in the right segment, and that's all. Can see the code. Yeah, now I can see. Okay, now we'll have some other functions also. Say public int find, int left, and int right. We need to find the sum of this particular range, so we'll be returning in another function. We will be overloading the function left comma right comma 0, and now it's time to implement this private function. Okay, it will be int low, int high, int l, and int r, and int low. So if low is greater than the right limit, or the high is lower than the left limit, we can simply return 0 because it do not lie in the, say, this particular range is outside, like completely outside our desired range. And if in case this particular range is completely inside in our desired range, then we can do something like we can just return seg of node. Otherwise we will be finding the mid of the current range, and we will be running the sum from the left side and the sum from the right side. Okay, yeah. Now one more function we need to implement, that is update. Okay, let's say public int update. So int index and int value, we need to update the value at index. So again we will be calling a private function with some parameters. Okay, and say void update, it will be int low. Again the same thing will be there. Okay, so if low is equal to high, we will be making seg of node equal to val, and we will be returning from here, and we will be checking for the mid. If the current thing lies in the left side, we will be just updating the left side from low to mid, and in val will be same, and node will be like this thing. And otherwise, if it lies in the right side, then we will have like this. Okay, and also we must update the current thing. Okay, some spelling issues. Okay, and this segment tree class is now complete, even though it is quite big. Now we just have private sec tree sec function, and that sec will be nothing but a new object of type sec tree, or we are passing that a array to our sec tree class. And now we will be sec dot update. We can just call our update function, and we can just return sec dot find left right. Let's check if there are any compilation errors. I think there should be something. Okay, yeah. Okay, okay, it should be a void type thing. Okay, okay, null pointer exception sec of it is happening because we are not initializing our seg array. It should be 4 times the array size. Okay, for one case it like let's try to submit it. For one case it got accepted, and yeah, for all rest of the cases also it got accepted. So you can see that we are beating 93% of the submissions, and I believe that rest 7% of the submission must be using the Fenway tree, because it is somewhat little faster but less powerful than segment tree. Hence like we use the segment tree here. Okay, now we have count a smaller number than after self. Okay, okay, so okay, let me just insert the code. So we have been given an integer array nums, and we need to return an integer array count, where count I will represent a number of smaller elements to the right side of nums I. So we can just see here, like there is no element that is okay, number of small, oh yeah, there is a single element on the right side of this particular element that is smaller than this one. And for this element we can see that there are two elements that are on the right side and are smaller. Okay, so we can see that the nums I can range from 10 power minus 10 power 4 to 10 power 4, and okay, we will not solve for this constraint. Let me clear you, we will solve if these are from 10 power 9 to minus 10 power 9, because that's like even more difficult problem. I would not say difficult, it is somewhat like quite tricky and observation based. Once you know the technique, you can like even solve from 10 power 18 to minus 10 power 18, because the number of unique elements can be up to array size only. That's the complete logic there. Okay, so I should like I would like to do like copy this class, because no need to write this much code again. Okay. Even though it is for like calculating the count of some particular range, but yeah, I think we need that thing only. Yeah. So first of all, we will be having a list of integer. Say private list of integers list, and for all integer in nums we will be adding that in our list. Okay, we are doing because the sorting function of the array is not good. Like lead code uses Java 8, and sometimes the array dot sort function uses ns got time complexity, hence we are using the list. Now we will have a hash map that will like technically this thing is called a coordinate compression, but like this thing is mapping the numbers to their indexes in the sorted form. I would say that. So, and also we need to take care of duplicates. Okay, and okay, let's define an array. Here that length. So if the map do not contain any entry for list.get of I, we will be putting list.get of I will be hm dot size. Okay. Otherwise, not otherwise, like it will be the case only. Otherwise, we will be not doing anything. Now the real question begins. We need to count the number of elements on the right side. So for okay, also we will have some list of type integer, say answer equal to new linked list, because we are using linked list because we are proceeding from right to left, and every time we will be adding at the front. So if we are using, like adding any element at the front, then in array list the time complexity will become n square, while in the linked list it will be order n only, like adding all the n elements. Okay, so for I equal to n minus 1 till I less than minus 1, sorry, greater than minus 1. Okay, also we need our segment tree variable here. So let's say private seg tree seg will be new seg tree. And now we need to modify in the case, because we now need not to implement the build function. Instead we will be passing the length. That's it. Now this is not required, this is required, and this is not required, this is not required, again this is not required here. Yeah. And what will be the length will be the size of the array. Okay, size of the array now. Just have one more thing here. We will be having if left is greater than right, we will be returning a 0. Additional check. So answer dot add seg dot find hm dot get a of I plus 1 till hm dot size, or maybe hm dot size, and this will be hm dot size. Unless, like if we are using that many times, let's define in some variable one itself to have a slight performance boost. Okay, let's see. Yeah, I think the find function is finished. Okay, yeah. And the seg dot update seg dot find, not seg dot find, hm dot get a of I comma 1. And now we need to update our thing. Maybe even we don't need 1 there. Where is the update function? Instead of int val, we will not pass anything, and simply here also we need not to pass anything. Again in this recursive calls also we will not pass anything, and it will be not val, it will be just plus plus, because we are incrementing once. That's it. And I guess add, it should be add first, and we can just return our answer. I think it should be fine. Okay, it should be a, it should be contains key, okay, it cannot find the function add first. It was a linked list only, no? And first I think there is a function, let me see, list add first. Okay, it happens in linked list only. Okay, so this will not be possible. So let's define it to be, yeah, we can just reverse the string at last. Reverse answer. Okay, HM is null. We also need to define our HM. Now we have some wrong answers. We are saying 0, 0, 1 and 2, and in this case it is fine. In this case also it is fine, but here it is wrong. We are putting 0, 0 and 1 that are smaller than. Okay, I am counting the greater. So got it. It should be from 0 to HM.get AI minus 1. Yeah. Now let's try to submit it. Okay, it got accepted, but I'm not happy with the number of people I'm waiting. I'm waiting only 39% of the submissions. Why it is happening? Okay, why it is happening? Let's say a small performance boost there. I'm using. I can get A of I. It should be K minus 1, and it should be K here. Now let's try to do it again. Yeah, because key is there. Okay. Key. Okay, now submitting it. Only 5 millisecond boost. What we can do instead of, okay, we are using array list only. If we use our linked list, can we see any jump? Okay, time limit exceeded in the linked list. Okay, but time limit exceeded should not have happened. At last won't work, so let it be array list only. Okay. Let's see what I've done in this submission. Oh, got it. I'm using a Fenwick tree, that's why it's happening. But that Fenwick tree submission, I don't think it would work in the higher constraints. But this would give the same performance even in the higher constraints. So I can say that this code is much more useful. So I'm not doing anything great here. I'm just sorting the things and then iterating from right to left and increasing the number of occurrences of that element by 1 in the segment, and then for each element I'm counting the number of elements from ranging from 0 to what should I say, from 0 to the index in the sorted order minus 1. In that range, if the number of count of elements that are occurring, we are just counting that things. Okay, now I think we can go to the next question, that is count of range sum. Why this is opening? Okay, so I have attempted to this question well, and I can solve it in the October last year. Let's see if I can solve this now. So given an integer array and two integer lower and upper, it is the number of range sums that lie in the lower and upper inclusive. Interesting. And so it is the count of numbers that can lie in that thing. Okay, that can lie in the range of lower to upper. And negative numbers are also there, so which will make the thing even more difficult. So how can we do that? Then range sums that lie in lower to upper inclusive. Mhm. Seems to be a difficult question. Number of elements in nums between indexes I and j. Or okay, lower to upper should be the range of the range sum. Okay. So the array size is 10 power 5, so we can't have any n square algorithm. Obviously, we can do something in n log n only. Also, the order should not be changed, otherwise, the purpose of question will be like not be fulfilled. Mm-hmm. Mm-hmm. So I can't think anything. Can I take some hint from here there? Related topics I know, similar question. Mm-hmm. Hints are not there. Okay, hints are not there. Maybe the solution headings here. My solution summary, divide and conquer. Merge sort, people are saying merge sort. And level solution. Let me see the solution itself. Mm-hmm. Okay, what they are doing, unable to understand. So first of all, they are using the val set and okay, then some will be added. Okay, then val set adds some. Okay, prefix sum, all the prefix sums will be added into the val set. Now val array will be val set to array new long 0. What is new long 0? I can think. Okay, and now this val array will be sorted and build segment tree root. Okay, okay, so I can say that I will be unable to solve this question, so better to leave that. Okay, that's all for the video.